Okay, we're going to be doing questions 51 to 56. I'm not doing all of them, but most anyway. Number 51, it has this thing about Brazil where Brazil currently has 1.4 million miles, square miles of rainforest, and in 50 years, they want to at least have 1.2 million. So the basic idea is somebody's cutting down all their trees, businesses or somebody is cutting down all their trees, and they want to restrict it so that in 50 years they still have a sizable rainforest. So the way we'll do this is we'll say the current is 1,400 years. I'm sorry, 1,400 years. 1.4 million square miles. And every year we're going to subtract out a certain amount. How many years will we do that? 50. Okay, by the end of that, it says that we're supposed to be having more than 1,200,000 square miles. Okay, so that's the inequality that you should initially set up. Now, subtract 1,400,000 from both sides. So again, we're subtracting 1,400,000 from both sides, and I'm not writing that out. But when you do subtract it, you get negative 200,000. Now divide by negative 50. We're trying to isolate x. So divide by negative 50. Notice that the symbol switches. It becomes less than. And let's see, that is 4,000. So each year, you have to cut down less than 4,000 square miles of trees. If more than that are cut down, then you're going to end up having too few trees 50 years from now. Okay, the second one, 52, I'm skipping. If you have issues with it, go to Hot Math. 53, Clifford thinks that x equals 7 is a solution to this inequality. So I'm just going to put 7 in. 3 times 7 minus 2 is less than or equal to 4. That'd be 3 times 5. So 3 times 5 less than or equal to 4. And that says 15 is less than or equal to 4. So we have to say, nope, that's not true. 7 is not a solution to that inequality. 54. The first part is graphing this inequality. We should all be pretty strong on realizing the start and the growth. In this case, start at negative 5. We're growing down 1 over 1. My line's about to be really sloppy. But it should be a solid line. Going really, really slow. But anyway, that should be as close to a line as that's as close as I can get it on this. And then to decide which way to shade, you should take a point. The easiest point to test is 0, 0. So we'll plug 0 in for y and 0 in for x. So notice it was this. I put zeros in, and we're going to see, okay, that's 5. Is 0 less than 5? Yeah, sure. So that point works. So I'll indicate that here, saying, okay, that's a good point right there. So everything on its side will work. So I'll just take out a shading color and all of this stuff. It's going to be a little hard for me to color in the lines. Sounds just about like kindergarten. So anyway, shade all this stuff in. It's all of these values here. Okay, you get the point. Okay, the next one is the inequality that's shown on the top there. It's y is greater than 2/3 x minus 1. So we start at negative 1. And we rise to run 3. Rise to run 3. Rise to run 3. Okay. Now, since it's not equal to, we make a dotted line, and I have a little tool to do that. So it looks something like this. That went a lot better than the last one. And we should have arrows on it to indicate that it keeps going in that direction. Now we're going to test a value. Again, 0, 0 is a pretty good value to test. Notice I would not use 0, 0 if it was on the line itself. So 0 greater than 2/3 times 0 minus 1. 0 is really nice because it gets rid of that fraction if you're not really strong with fractions. And now you say to yourself, is 0 greater than -1? Yes, it is. So we'll put a point down there to tell ourselves, okay, make sure you shade on this side, and then you shade all this stuff in. Okay, so anything on that top left side is a solution. You can check that out for another second. Okay, number 55 is it's actually a system of equations. Zach has 718 in his account. You should think, okay, 718, he has that now. That's his start. He automatically withdraws 14 every month. So his growth is to subtract $14 a month. Okay, there's our rule for Zach. Just as a little quick quiz here, think X represents every what? Is it money? Months? In this case, X is months. And then Y value will tell you how much money he has. Christian has 212 in his account, so we're going to start with 212, and he adds $32 a month. So 32x plus 212. To find out where they meet, we need to solve this system of equations. We have three methods to do it. That is substitution, elimination, and equal values, remembering that substitution and equal values are very similar. In this one, we're going to use equal values. Negative 14x plus 718 equals 32x plus 212. I'm going to add 14 to both sides. 718 equals 46x plus 212. Subtract 212 from both sides. Minus 212. This will be 506 equals 46x. And right about now, I really wish I had a calculator. I'm going to go get one. Hold on. I know. Shame on me. I'm a math teacher. I should just do that in my head. But it's late in the day. That's my excuse. So x equals 11. Now that tells you x are the number of months, and that's what they ask. They actually say, when will they have the same amount of money? It's 11 months. If we needed to know how much money they will have, we'd put 11 back in for x, and we'd find the total amount of money they have. Okay? Out of curiosity, let me just calculate that. 32 times 11 plus 212 is 564. Okay, and the last one is this one, and I'm assuming that several of you will have issues with it, but I already made a graph here, and I decided on my scale, and just the way you should. Just think about it, think about what you do, the way you graph, what you're most comfortable with. I picked 1 for my x values, and I should have labeled my axes. This is the game number. That's a really ugly word, game. And these are the baskets. Yeah, I think I'll draw a little picture of a basket, just because. Why not? That's the rim. Okay, this is one sweet-looking basket. All right. So game number 1 has 6 baskets. That's somewhere around there. Game number 2 has 11. 2 has 11. Something like that. Number 3 has 18. It's maybe here-ish. 4 has 25. And obviously I'm not doing the most accurate job of graphing this, but we're only looking for an estimate in the problem anyway. So it looks like there's kind of a nice solid line here. If I were to extend my line, I don't know, that's close anyway to what I would think of my line. It looks like the line goes up 5 over 31. It starts at 0. So let's just call it up 31 over 5. So let's just call it up 30 over 5. So our slope will actually be 30 over 5, and that's just 6. That's what we're going to think he roughly makes about 6 baskets per game. So our equation would be y equals 6x plus 0 as the start. And if we want to know what happens at 15 games, you do 6 times 15, add 0 to it. That's 90. And anyway, that's decent as to where I thought it was based on my graph. It looks like it's about here, which would be 90 something. Anyway, we got a guess of 90 from the picture. All right, bye.